Hi, this project is related to basically the MATLAB-based analysis of projectile motion according to range, height, and the velocity. The projectile motion is used in different rockets algorithm. Its uses in different graphical representation of trajectories according to different initial conditions as well as the dynamics of projectile motion shedding lights, including we have used the shedding of lights. It's the complex relationship between the variables and governs the phenomena as well. Okay, so I have added the complete abstract for like how its velocity, its angle of projection, its air resistance, its factors of different environmental effects are added in this project. So I have added the abstract, then introduction. Introduction is basically the I have added the detailed introduction of the projectile motion according to different angles with like this is the figures of projectile motion for vertical velocity. Like the main object starts from zero position to position of B with the using of different angles. Like here it uses the angle is theta, then it uses the angle is u cos theta, use sine theta, then it also added the angle of different height with the places of cos theta. Use basically the height according to x-axis and the y-axis as well. Okay, like here it y-axis when the object moving from upper place to lower place, then the y-axis goes in negative side, and while x-axis is in positive side. So that's why we have included that the negative u sine theta in this case. Okay, and the u cos theta mean cos theta represents the x-axis and sine theta represents the y-axis basically. So here is the range as well as the height as well. So I have added the key concepts according to the importance of projectile motion with the problem statement and the design methodology, in which I have used these equations for the horizontal motion, for the vertical motion as well. The range equations are like this one, like how the sine theta with the square root of sine theta as well, and the how cos theta, how height of the projectile object predicts according to different horizontal and the vertical distances covered. Then the MATLAB simulation is included in it, and the simulation parameters we have used the time step, we have used the numerical integration, visualization, applications, and then advantages as well. So results and discussion are added in this place where we have used the projectiles motions according to different height level with the x-axis and y-axis. X-axis represents the horizontal axis and the y-axis represents the vertical axis. And then we have added this one, the range, which is angle of projection basically. And this one is represents the maximum height versus initial velocity. This is also represents the effects of air resistance on projectile trajectory, basically how air resistance changes the direction of object from during the projectile motion. And then the velocity components are added, like the comparison of trajectories of four different angles of projection as well. And this one is the acceleration components as well, okay, which provides us the lost time, flight of time, and this is initial velocity. Height versus time with maximum height marks, like how kinetic energy travel from one place to another place, like shifted when the object moves horizontally, like then kinetic energy works. When the object moves from high to low side, then the potential energy generate. The potential energy according to the height of projection, like the when it object moves upper side, then the potential energy is positive. When um, it provides the height object move from upper to lower side, then potential energy provides the negative side. It means the potential energy object provides the potential energy to the users. Then yes, this one is basically the velocity components versus time, and this provides us a trajectory comparison for different masses basically. Like when the mass is high, the object will move with the lower height. When the mass is low, the object move with higher height. Like a height and the mass having the inversely proportional each other. Range versus initial velocity, and then I have added the conclusion and the future work with the references. Let me just, yes, this one is the MATLAB code I have added with the initial conditions, calculated with the derived equations, used time of flight, time vector with the, including the trajectory plots as well. Okay, let me just run it, and I'll get the outputs like this. Yes, this one. Position for the projectile motions according to different height versus air velocity according to different acceleration components. See, all the outputs are added here. We are getting the outputs like which we added in the article. Okay, if you need to ask anything, you just call me. Thank you.